So good morning. Now we are going for the next concept that's called as piecewise functions. So in these piecewise functions, we are going to see about majorly like absolute value function, greatest integer function, least integer function, and also we are going to see about fractional part function. And so these are the many major important functions what we have. These all functions are called as piecewise functions. So first type of function what we call it as a absolute value function or modulus function. Modulus function or absolute value function. So a function of the form f of x is equals to mod x, or a function of the form y is equals to mod x is said to be called an absolute value function or modulus function. And for this function, the domain of the function would be the set of real numbers, that is, the function is defined for every real number, so therefore the domain of the function is going to be R, and particularly in the case of mod x, and the range of the function is going to be any non-negative real number, that is, whatever number you are going to take in the place of x, the value of y is going to be a non-negative number. So the range of this function mod x is going to be right from a left closed interval 0 to infinity. That means it can be a non-negative real number. So before going to this function, absolute value function, we need to know about what is meant by absolute value of a real number. So we need to discuss about the absolute value of a real number and the properties of the absolute value of the real number. So one can understand the absolute value function only when they are perfect with the properties of the absolute value. So let's go ahead with the properties of the absolute value of a real number. So absolute value or modulus of a real number x. So absolute value or modulus value of a real number x is already seen in the lower classes. The absolute value of any real number x is going to be the number itself if whenever x is going to be a positive number or a number equal to 0, whereas the absolute value of a real number x is going to be equal to minus x if whenever x is going to be negative. So this is the definition of modulus of a real number. So let's go with some examples. So modulus of say minus 5 is going to be 5 itself. And so the basic definition of modulus of a real number is the number itself neglecting this sign. But when we follow the definition of the modulus of real number, whenever x is taken as a negative number, then to get the modulus value of the negative number, we need to multiply that number with one more minus sign. So in case if you want to find the modulus of minus 5, we need to multiply a minus sign for the number what is given there. So it gives us the value as 5. So the absolute value of minus 5 is going to be equal to 5. So the absolute value of plus 5, if it is the number is going to be a positive number, the number is going to be a positive number, the absolute value of the number is going to remain same, is going to be 5. And the absolute value of a 0, if it is 0, then the absolute value of a number 0 is going to be remain same, 0 itself. So what we can understand is, we can understand that the absolute value of any real number is never negative. If you observe carefully, it is never negative, that is, it can be either positive value or it can be a 0, but the absolute value of a number, real number, is never negative. So the important property or important note regarding the absolute value of a real number is the absolute value of a real number is never negative. The absolute value of a real number is never negative. So as because we already have discussed about the absolute value of a real number, now let us check about the absolute value equations and inequations and their solutions, or we can say that the properties of absolute value. So for the properties of absolute value of real number, let us see the properties of absolute value of real number. You can say properties of modulus of x. So if, for example, the first property, if we have got a modulus of x such a way that it is going to be equals to a positive number a, then what is going to be the solution for such kind of equation? So the equation of the form mod x equals to a is called as the absolute value equation, and the value of x which satisfies this equation is going to be called as a solution for this absolute value equation. So what is going to be the solution for such kind of equation, for which I'll go with some example. Let us take some example. Say absolute value of x is equal to say 5. So tell me here what are the values of x which satisfies this equation. The value of x which satisfies the equation is plus 5 or minus 5. So modulus of plus 5 is going to be equal to 5, and modulus of minus 5 is also equals to 5. Therefore the value of x is going to be equals to plus 5, or it can be equals to minus 5. Observe carefully that I have taken a value is positive. So whenever a value is taken as a positive real number, then the solution for it is going to be x can be equals to plus a, or x can be equals to minus a. So this is going to be a very important property, and this equation what we got here is called as a absolute value equation. And here we have taken the value of a is going to be positive. If a is not positive, so what happens in a case? So property number 2. So absolute value of x is equals to a, where a is equal to 0. In this case, what are going to be the solutions for the equation? So we go with the example. Let's suppose that mod x is equals to 0. So what are the values of x which is going to satisfy the equation? Here, because the right hand side is 0, whatever the value of x you take here, it should satisfy the equation. So the only number which satisfies the equation is 0, because for a 0 is neither positive nor negative. You need not consider about plus 0 and minus 0. It's 0 itself. So the only solution for this equation is going to be x equal to 0. So for example, I take one more equation, say I take mod x minus 2 is equal to 0. So what is the solution for this equation? So whenever the right hand side is 0, the only value of x which satisfies this equation is going to be 0. So that means the whole value of this expression should be 0, and there is no plus 0 or minus 0. So we'll have only one solution for it. That means the solution is obtained by equating this x term to 0, that is x minus 2 equal to 0. That means x is equals to 2. So x is equals to 2 is the only solution for this equation. So whenever the value on the right hand side is 0, the only solution we have for the equation is x equals to a. So this is going to be the important property on modulus of function. So important property of modulus of x. So the third property is, if I take modulus of x equals to a, where a is going to be a negative real number. So in this case, what happens? Let's go through some example. Let us see some examples. Say mod x is equals to say minus 5. So try to find out some values of x which is going to satisfy this equation. So whatever number you're going to substitute in the place of x, the modulus of that number will never give you a negative result. So that means there is no real number, or there is no value of x which is going to satisfy the equation. So in this case, we can say that is there is no solution. That is this case there is no solution, because whatever the value of x you take in the place of x here, the absolute value of x is never negative. So there's no value of x is going to satisfy the equation. So in this case, the value is going to be not exist. That means there is no solution for such kind of equation. So I have considered some few properties about the absolute value equations. Now we go with the absolute value in equations. Let's suppose that I take mod x less than a. So what is going to be the solution of it in case a is going to be positive? So for which I am going to explain you through the example. Let me go to the example here. So example, say I want to solve an equation where I take the value as the equation as mod x less than 5, and such kind of inequations are called as absolute value inequations. In the first three we have seen absolute value equations. So whenever you have a absolute value equation, these are the ways we can solve the absolute value equations. Now coming for the absolute value inequations, so mod x less than a. If a is positive number, so I have gone through some example where I have taken the value of a as a positive number. If mod x is less than 5, then tell me what are the numbers on the number line which are going to satisfy this equation. So let's say about 0 and minus 5 and plus 5. Observe carefully on the number line what are the numbers you take right from minus 5 to plus 5, that is not including minus 5 and plus 5. What are the numbers you take between minus 5 and 5 that are going to satisfy this inequation? Like for example, if I take minus 5, modulus of minus 5 is 5. 5 is not less than 5. So minus 5 does not satisfy the inequation. Even 5 also does not satisfy the inequation. Whereas any number between minus 5 and 5, we take say minus 4. If I take mod of minus 4 is going to be 4. 4 is less than 5. So take 4, we get modulus of 4 as well as the 4 less than 5. So what you can understand is you can understand that any number taken between minus 5 and 5 is going to satisfy this inequation. So exactly whenever a is positive number and if you want to solve this absolute value inequation, the solution for this inequation is going to be a number lying between minus a and a. And exactly if you have got a less than or equals to, that is if I am going to include a, now obviously the solution is going to be including the minus a and plus a, that is minus a less than or equal to x less than or equals to a. So now coming for the next condition, that is the next type of inequation where a is not in the positive, that means a is 0. Let's suppose that I take mod x less than a where a is going to be equal to 0. Let us try to do some example based upon this condition. Here that means I am going to consider an absolute value inequation where the right hand side is going to be equal to 0. So whenever the right hand side is 0, we know that modulus of any value of number is never negative. So whatever number I take, it will never give you less than 0. So in this case, you will get no solution. So exactly whenever the right hand side of this number of this term is going to be equal to 0, then you can say that there is no solution. And coming for the next case, that is in case we have got absolute value of x less than a where a is negative. When a is negative, that is if I go with some examples, say mod x less than minus 5. So let's check for some numbers where the modulus of that x value is going to satisfy this equation. So here whatever the number I am going to put here, the value is going to become positive, and positive value is never less than the negative number. So therefore in this case also we do not have any kind of solution. So whenever a is negative, we will not have any solution. So we have no solution. Now so far we have seen the absolute value inequations of less than type. So same way, if I go with the absolute value inequations of greater than type, say mod x greater than a, where a is going to be positive. So if a is going to be positive, what happens? So if I take the value of a as a positive number and instead of less than type I take as a greater than type, so what is going to be the solution for the inequation? So I go ahead with the example where mod x is going to be greater than 5. So here try to observe it carefully again. So I take a number line where the mark with the numbers minus 5 and 5 and of course 0. Now if you observe carefully, what are the numbers I substitute are going to satisfy the equation are nothing but the numbers less than minus 5. The numbers less than minus, not including minus 5, but number less than minus 5 or any number greater than 5 are going to satisfy this inequation. Say for example, if I take a number less than minus 5, that is going to be minus 6. If I substitute minus 6, mod of minus 6 is going to be 6. That means 6 is going to be greater than 5. So minus 6 has satisfied this inequation. Not only minus 6, any number like minus 7, minus 8 and so on, any number less than minus 5 are going to satisfy this inequation. Exactly same way, any number more than 5 are also going to satisfy this inequation. So the solution for this inequation is going to be in two intervals, that is x can be taken from this interval or it can be taken from this interval, that is x can be any number less than minus 5 or it can be from other interval, that is x can be taken greater than 5. So the solution for such kind of inequation where the value of a is positive, in this case the value of x does not lie between minus a and a, that means it will lie less than minus a, or x can be taken any number less than minus a, or x can be taken any number greater than a. So now the greater than type we have got for the next one, that is going to be mod x greater than a in case a is going to be equal to 0. What happens if I take the right hand side is going to be 0? So mod x greater than 0. So tell me like what kind of numbers are going to satisfy this inequation. So observe carefully, whatever the value of x I take, either maybe positive number or a negative number, they are going to satisfy the equation. Say right from 0.1 minus 0.1 any number except 0. So what are the number I put? Like for example, if I put 0.1, mod of 0.1 is going to be 0.1 is going to be greater than 0. Or if I take minus 0.1, mod of minus 0.1 is 0.1. So 0.1 is also again greater than 0. So on the number line, every number on the real number line except 0, any number on the number line, either it may be positive side or negative side except 0, whatever number you take it. So all our numbers, all the real numbers are going to satisfy this inequation, whereas 0 does not satisfy an equation. So here we can say that the value of x belongs to every real number on the number line except for 0. So the solution for this case is going to be every real number except 0. So in this case the value is going to be every real number except 0. So x should belong to that particular number except 0. So coming for the final thing, that is going to be mod x more greater than a, where a is going to be negative. So do we have any chance where the value of mod x is going to be greater than? So I'll take an example. So mod x greater than minus 5. Mod x greater than minus 5. So what kind of numbers are going to satisfy this inequation? Are there any numbers that are not going to satisfy the inequation, or every number on number line satisfies it? So as we already know that the absolute value of a real number is never negative, so it means it is going to be either a positive number or going to be 0. Whatever number you substitute here, whatever number taken from number line you substitute here, that number is going to be either a positive number or going to be a 0. That means either a 0 or a positive number is always greater than a negative number. That means the entire real number set or the entire real number line, every number on the real number line is going to satisfy this inequation. So in this case x belongs to R. That means any real number can satisfy this inequation. So here we have got some properties of the absolute value of variable x. So based upon this we can solve some of the equations or inequations given in your problem. So let's go ahead with the questions or example sums. So they ask us to find the solution for the inequation mod x greater than 3. So mod x greater than 3, obviously it is in the form of mod x greater than a, where a is going to be positive number. So the answer for it is the value of x does not lie between minus 3 and 3. So it does not lie between minus 3 and 3. So the solution for it is going to be either any number less than, so we have or we know that mod x greater than a, where a greater than 0 implies that the value of x is less than minus a, or it must be greater than a. Therefore, because a is a positive number here, mod x greater than 3 implies that x should be either a number less than minus 3 or x should be a number greater than 3. Therefore, the solution is going to be a number not lying between minus 3 and 3. So, same way, if I go with other inequation, say absolute value inequation like mod x less than or equal to 3. Mod x less than or equal to 3. So, mod x less than or equal to 3 is obviously where a is going to be a positive value, because a is going to be a positive value. It's going to be this kind of property where we have got less than or equal to. When we got less than or equal to, the value of minus a and a also can be included. And exactly same thing, if in case we have got mod x greater than or equal to a, and here obviously the solution becomes x less than or equal to minus a or x greater than or equals to a. So, make the necessary changes as per the inequation required. So, here mod x less than or equal to 3 is of this type, where 3 is going to be a positive number. Therefore, the value of x lies between minus 3 and 3, including minus 3 and 3. Therefore, the solution for that inequation is going to be any number between minus 3 and 3, including minus 3 and 3. So, these are the properties of the absolute value of the number. So, here we have discussed about the absolute value of a very real number x. So, because we came to know about the absolute value of real number x, so we can now discuss about the absolute value function. So, generally a function of the form f of x equal to mod x. So, function of the form absolute value function. So, a function of the form f of x is equal to mod x is said to be a absolute value function, and the domain of this kind of function, or domain of this function, is going to be any real number, because every real number is going to give you some result, or it's defined at every real number. Therefore, the domain of this function is going to be R, and the range of this function, because the value of mod x will never give you a negative number, that means the range can be any number between 0 to infinity, including 0. So, the function of the form f of x equals to mod x is said to be a absolute value function. And you have to be very careful when we are discussing about the domain. So, the domain concept we will be discussing in the next aim. So, we have seen the first type of piecewise function, that is going to be absolute value function. So, now we are going for the next type of function, that is called as the greatest integer function. So, before going to the greatest integer function, let me discuss about what is the greatest integral value of a variable. So, after discussing about the greatest integral value of the variable, we will discuss about the greatest integer function. As how we have seen the absolute value of a real number, the same way the greatest integer of a real number, or greatest integer value of a real number. So, the greatest integral